Here are all the 20 amino acids you need to know for the MCAT and how I memorized them. The first amino acid is glycine. Glycine's three-letter abbreviation is GLY. Its one-letter abbreviation is G. The side chain of glycine is a hydrogen atom. The memorization trick for glycine that I used is that glycine sounds kind of like glycine, and so the hydrogen side chain is just a little hydrogen guy. Its special properties are that it is nonpolar, but it is very small, so it could still be found on the outside of proteins on that hydrophilic surface, and also that it's not chiral. All the other amino acids are chiral. That's because two of the groups bound to the alpha carbon are hydrogen. The second amino acid is alanine. Alanine has the three-letter abbreviation ALA and the one-letter abbreviation A. The side chain of alanine is a methyl group, so it's a carbon with three hydrogens bound to it. The memorization trick I used for alanine is that there's a guy named Alan who has a head. So his head is the CH3. The special properties for alanine really just said it's nonpolar. Next is valine. Valine has the three-letter abbreviation VAL and the one-letter abbreviation V. The structure of valine is CH and then two CH3 groups. That is otherwise known as an isopropyl group. So the side chain of valine is just an isopropyl group. The memorization trick I used to remember valine is that the name starts with a V, which is sort of what an isopropyl group kind of looks like. Special properties, it's nonpolar. The next is leucine. Leucine has the three-letter abbreviation LEU and the one-letter abbreviation L. The side chain of leucine is exactly the same as the side chain of valine, except between that CH and the alpha carbon, there's an extra CH2. So it's like valine, but it's a little bit longer. I remembered leucine by thinking of a person, which is sort of what leucine looks like. Like the isopropyl group is legs, and the extra CH2 is like its hips. The special properties for leucine is that it is nonpolar, just like all of the ones I've mentioned so far. The next amino acid is isoleucine. Isoleucine's three-letter abbreviation is ILE, and its one-letter abbreviation is I. Isoleucine is an isomer of leucine. So leucine, CH2, and then an isopropyl group. Isoleucine is the same, except you take one of the methyl groups at the end of leucine and you plop it onto that CH2, making it a CH group with a methyl group coming off that is still bound to the rest of the normal structure of leucine. That's isoleucine. It's an isomer of leucine. That's also how I memorized the structure, because it's isoleucine. It's in the name. The properties are that it's nonpolar and that it's aliphatic. The next amino acid is proline. The three-letter abbreviation for proline is PRO. The one-letter abbreviation for proline is P. So the structure of proline is that it's an aliphatic hydrocarbon chain that comes off of the alpha carbon and then binds back to the amino group of the amino acid backbone. I remembered this by thinking of proline as a house. It kind of looks like a house if you put those 5 members of the ring in a certain orientation in a drawing of the molecule. The special properties for proline are distinct. It introduces a kink into the protein unlike any other amino acid. So it introduces a kink in the amino acid chain that makes up the protein. The next amino acid is methionine. Methionine has the three-letter abbreviation MET and the one-letter abbreviation M. The structure of methionine is CH2, CH2, sulfur, and then CH3. The memorization trick I used for methionine's structure is to think of the baseball team, the Mets. So I would take the name the Mets and I would say M for methyl, E for ethyl, T for thion, which is the ancient Greek word for sulfur actually, and then S for saturated carbon at the end. So pretty janky mnemonic there, but CH2, CH2, sulfur, CH3, That is the structure of methionine. It is nonpolar, but it does have that sulfur atom. The next amino acid is phenylalanine. Phenylalanine's 3-letter abbreviation is PHE. Phenylalanine's 1-letter abbreviation is F. The side chain of phenylalanine is the side chain of alanine, except you add on a 6-membered carbon aromatic ring, aka a benzene ring. So you take that CH3, you plop on the benzene ring, and it becomes a CH2 with a benzene ring. That is the side chain structure of phenylalanine. The way I remember the side chain of phenylalanine was to think of alanine side chain, which is just a carbon, except you add on a benzene ring. Well, another name for a benzene ring in organic chemistry is a phenyl group. So it literally is just alanine plus a phenyl group. So the side chain is CH2 plus that 6-membered aromatic benzene ring. It's alanine plus the phenyl group. It's in the name. The next amino acid is tryptophan. Tryptophan has the 3-letter abbreviation TRP and the 1-letter abbreviation W. The structure of tryptophan is what is called an indole group. It looks like this. The way that I remembered tryptophan was to just brute force memorize the indole group, but also remember the 1-letter abbreviation by thinking tryptophan. I didn't come up with that. The next amino acid is tyrosine. The 3-letter abbreviation for tyrosine is TYR. The 1-letter abbreviation for tyrosine is Y. The structure of tyrosine's side chain is the same as phenylalanine, except you add on a hydroxyl group to the other side of that benzene ring, opposite from the alpha carbon. So for tyrosine, you have what looks like a tire in a car. That's how I remembered tyrosine. Its special properties is that since it has a hydroxyl group, it could be phosphorylated. So that hydroxyl could be turned to a phosphate group. The next amino acid is cysteine. Cysteine. The 3-letter abbreviation of cysteine is CYS. The 1-letter abbreviation of cysteine is C. The side chain of cysteine is a CH2 group and then a thiol group, which is the sulfur version of a hydroxyl group. So you take a hydroxyl group, you replace the oxygen with sulfur, and what you have is a thiol group. The way I remembered cysteine was to think of the Sistine Chapel. Bear with me. The Sistine Chapel has a roof that is a connection between the two walls. Very similarly, cysteine can connect two sulfurs from two different cysteines to become cysteine. The Sistine Chapel is like cysteine in that it binds together the two walls to make a roof. The special property is that it makes that kind of bond, which is called a disulfide bridge. It is also called cysteine because that's the name of two cysteines bonded together in that way. The next amino acid is serine. The 3-letter abbreviation for serine is SER. The 1-letter abbreviation for serine is S. The side chain of serine is the same as cysteine, except it actually is just a hydroxyl group. So for serine, you have CH2 and then a hydroxyl group. I didn't have a memory trick for serine. The next amino acid is threonine. Threonine has the 3-letter abbreviation THR and the 1-letter abbreviation T. The side chain of threonine is the same as the side chain of serine, except you add on a methyl group to the carbon before the hydroxyl. So the way I remembered threonine was to remember 3. You have 3 groups that are coming off of that alpha carbon. 1 CH group, 1 CH3 group, and 1 hydroxyl group. A special property of threonine is that that side chain it actually has another chiral center. For most amino acids, it's the alpha carbon that is the only chiral center, but for threonine, it's the alpha carbon and also that carbon in the middle of the side chain. The next amino acid is asparagine. The three-letter abbreviation for asparagine is ASN. The one-letter abbreviation for asparagine is N. The side chain of asparagine is a CH2 followed by an amide group, which is a carbon with a carbonyl and an amino group bound to it. It is the same as a carboxylic acid, except instead of a hydroxyl group, it has an amino group. The way I remembered asparagine's side chain is to think of it in context with its sister amino acid, glutamine, and the sister amino acid of those two amino acids, which are aspartic acid or aspartate and glutamic acid or glutamate. So let's talk about those three other amino acids now and memorize them together. Glutamine has the three-letter abbreviation GLN and the one-letter abbreviation Q. I remember that one-letter abbreviation by thinking, I question why glutamine has Q as its one-letter abbreviation. The structure of glutamine is the same as the structure of asparagine, except it has an extra CH2 between the alpha carbon and the carboxylic amide group. Glutamine, like asparagine, is polar due to the differences in electronegativity in the atoms of its side chain. The next amino acid is aspartic acid or aspartate. The three-letter abbreviation for aspartate is ASP. The one-letter abbreviation for aspartate is D. The structure of aspartate is the same as for asparagine, except rather than an amide group, it's a carboxylic acid. So, aspartic acid's structure is a CH2 followed by a carboxyl group, which is a carbon with a carbonyl group and a hydroxyl group. Important to note about the side chain of aspartate or aspartic acid is that it has two forms that are both commonly seen. So, aspartic acid is the form where that carboxylic acid group still has its hydrogen. Aspartate is the form where the carboxylic acid group has lost its hydrogen, thus gaining a negative charge. The way that I remembered the one-letter abbreviation for aspartate is to think of the word date. So, do you want to go on a date with me? Well, that would be pretty negative because all I talk about is amino acids, and so aspartate is a negatively charged amino acid. The next amino acid is glutamic acid, otherwise known as glutamate. So it's the same structure as aspartate, except with an extra CH2. The three-letter abbreviation for glutamate is GLU, and the one-letter abbreviation for glutamate is E. Like aspartate, it has a negatively charged side chain when the hydrogen is removed from that carboxylic acid group. So, putting all those four amino acids that I just mentioned together, you have two amides and two carboxylic acids. They follow a similar convention. As is suggested by the names of aspartic acid and glutamic acids, they're acidic. That's the special property. The next amino acid is lysine. Lysine has the three-letter abbreviation LYS and the one-letter abbreviation K. The side chain of lysine is CH2, 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 an amino group. I remember the side chain of lysine by thinking of a bottle of Lysol. So, bottle kind of sounds like butyl, which is a 4-carbon chain in organic chemistry. So it goes methyl, ethyl, propyl, butyl, and then an amino group. The one-letter abbreviation of lysine being K, I remembered that by thinking of how Lysol kills bacteria. The special property of lysine is that it is basic because it has an amino group. The next amino acid is arginine. Arginine has the three-letter abbreviation ARG and the one-letter abbreviation R. The side chain of arginine is CH2, 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 followed by the guanidinium group, which is a carbon which is bound to 3 nitrogens. In arginine, one of those nitrogens is bound to that CH2, CH2, CH2 chain. I remembered the side chain of arginine by thinking of pirates saying R. In the case of arginine, there are 3 pirates, and those are nautical pirates, so they are N or nitrogen. They are surrounding the central carbon. The special property of arginine is that it is pretty basic. That group that I mentioned at the end is pretty basic, even more basic than lysine. The final amino acid is histidine. The 3-letter abbreviation of histidine is HIS. The 1-letter abbreviation of histidine is H. The side chain of histidine is an imidazole group. The imidazole group is a 5-membered aromatic ring which has 2 nitrogens and 3 carbons. In histidine, that side chain is connected directly to the alpha carbon via one of the aromatic carbons on that 5-membered ring. The way that I remembered histidine was brute force memorization. Histidine's special property is that it's kind of basic, but not really, which makes it a really good proton shuttle, so you'll often see it in the active site of enzymes when it's time to do some sort of acid-base catalysis. I am for hire as an MCAT tutor. I still have open slots for new MCAT students, so if you are preparing for the exam right now, then I encourage you to visit my website, aidenmcat.com, learn more about me and my services, and I would love to make this journey a little bit easier for you. Thanks again. Yeah, so this is how you get to my website. It's aidenmcat.com, and you can scroll, take a look at my latest video. I also host a podcast about the MCAT, testimonials. Go to book that free session, and it's going to take you through a few steps depending on when you're available on my schedule. And if you have any issues at any point in trying to book me, just either call that number or text that number at the bottom of the screen. I respond during my business hours, which are also at the bottom of the screen, or email me or send me a message on my website. And thank you again for watching.